Good evening to everyone. Welcome to my channel, Belagali's class. Friends, we are doing with factors that doing with direction cosines of a vector. Yes, my friends. Direction cosines of a vector A are scalar components of A cap. What is A cap? It is a unit vector in the direction of vector A. Yes, my friends. That definition is given. Even I have done examples based on that definition. After that, my friends, I gave another definition. This you know once again, my friends. Vector AB can be written as OB minus OA. Any vector can be converted in terms of its position vectors. First useful result. It is the space, my friends. If Pxyz is a point in the space, then OP, vector OP is called as position vector of the point P and is given as x coordinate is multiplied by I, j, k. They are the unit vectors along OX, OY, OZ. Therefore, it is xi plus yz plus zk. Then magnitude of OP is root x square plus y square plus z square. Yes, my friends. What is next? If alpha, beta, gamma are the angles made by the factor OP, then cos alpha, cos beta, cos gamma are called as direction cosines of the vector OP, denoted by LMN. Therefore, cos alpha is L, cos beta is M, cos gamma is M. This vector OP is nothing but vector R, my friends. It is nothing but vector R. This OP is the position vector of the point P, which is taken as vector R. Therefore, vector R, cos alpha, cos beta, cos gamma are the direction cosines of the vector R. Cos alpha, cos beta, cos gamma. Yes, my friends. Based on this, there is one example, good example, my friends. Show that the factor A equal to I plus j plus k is equally inclined with the coordinate axis OX, OY and OZ. Given factor A equal to I plus j plus k, then magnitude of A is what? Square root 1 plus 1 plus 1, which is root 3. A cap by definition, factor A divided by its magnitude, I plus j plus k upon root 3. Simplification, 1 by root 3 into I plus 1 by root 3 into j plus 1 by root 3 into k. Then direction cosines of vector A are scalar components of A cap. So, direction cosines of the vector A, I will repeat. Scalar components of A cap. Scalar components are coefficients of ijk, which are 1 by root 3, 1 by root 3, 1 by root 3. Therefore, direction cosines of the vector A are 1 by root 3, 1 by root 3, 1 by root 3. Name this as 1. Then my friends, I have explained another concept. That concept is what? If alpha, beta, gamma are the angles made by the vector A with OX, OY, OZ, then cos alpha, cos beta, cos gamma are the direction cosines of the vector A. You name this as 2. Yes, my friends. See, direction cosines of A are 1 by root 3, 1 by root 3, 1 by root 3. Direction cosines of vector A are cos alpha, cos beta, cos gamma. Cos alpha, cos beta, cos gamma. If you wanted to write separate it, separate here, my friends. Therefore, direction cosines of vector A equal to, my friend, cos alpha, cos beta, cos gamma. You name this as 2. name this as. Therefore, from 1 and 2, we get, see, direction cosines, compare them. Cos alpha is 1 by root 3, cos beta is 1 by root 3, cos gamma is also 1 by root 3. Written the same. Comparing 1 and 2, we get cos alpha is 1 by root 3, cos beta is 1 by root 3, cos gamma is 1 by root 3. From this, my friend, take cos this side, it becomes cos inverse alpha, cos inverse 1 by root 3, beta, cos inverse 1 by root 3, gamma, cos inverse 1 by root 3, alpha, beta, gamma. This, my friends. Therefore, from this, what about this? Cos inverse 1 by root 3, 1 by root 3, 1 by root 3, they are equal. So, alpha equal to beta equal to gamma equal to this. This shows that, see, what these, they are the inclination of what? This is OP, and my friends, this is alpha. This is alpha, this is beta, this is gamma. Hence, my friends, this is gamma. When alpha equal to beta equal to gamma means all the three, this vector is equally inclined. Alpha means with OX, beta means with OY, gamma means with OZ. This shows that the vector A is equally inclined with axis OX, OY, OZ. The same is written here. This shows that the given vector A is equally inclined with axis OX, OY and OZ. This is your example, my friends. Yes, this. Next is another definition or result, you can say. Direction ratios of a vector, direction ratios of a line or vector, anything, my friends, of a vector joining the points A, x1, y1, z1 and B, x2, y2, z2. Our direction ratios are x2 minus x1, y2 minus y1, z2 minus z1. This, my friends. And the direction cosines of the vector AB, direction cosines of it means what? Vector AB. Direction cosines of vector AB are x2 minus x1 upon magnitude of AB, y2 minus y1 upon magnitude of AB, z2 minus z1 upon magnitude of AB, where magnitude of AB is length AB. What is this length AB? Distance between the points A and B. Distance between the points A and B. You have to make use distance formula. Based on this result, my friends, you have one example. If A equal to 1, 2, minus 3, B equal to minus 1, minus 2, 1, then find the direction ratios and direction cosines of the vector AB. Yes, my friends, I will apply the same. I hope you have copied this. I wait for a minute. Please copy it. Yes, friends. Now I do that example. What you wanted? First you wanted distance between the points AB, that is magnitude of the vector AB. Then you have to write what? Directly the direction cosines of the vector x2 minus x1 upon this, y2 minus y1 upon this, z2 minus z1 upon this. Yes, my friends. That example now. Solution of that example. Yes, given A point A, what are the coordinates? 1, 2, minus 3. B equal to, B is minus 1, minus 2, 3. No, it is 1. Then magnitude of AB. Magnitude of AB is a distance AB. This is distance between A and B, which is square root of, yes, x2 minus x1 whole square plus y2 minus y1 whole square plus 1 minus of minus plus 3 whole square, which equal to square root minus 2 the whole square minus 4 the whole square, 4 the whole square, it is root 36 means it is 6, my friend. Therefore, magnitude of AB is 6. Magnitude of AB is 6. Yes. Then the direction cosines of factor AB are, yes, my friend, x2 minus x1 upon this. This is x2 minus x1 upon magnitude of AB, comma, y2 minus y1 upon magnitude of AB. This is z2 minus z1 upon magnitude of AB equal to, what is x2 minus x1? Minus 1 minus 1 upon AB 6, comma. Next is minus 2 upon 6. 1 minus of minus plus 3 upon 6 equal to minus 2 by 6 minus 4 by 6. This is 4 by 6, which is minus 1 by 3 minus 2 by 3, and it is plus 2 by 3. These are direction cosines of the vector joining the points A and B, vector or line. Vector or line joining the points. Joining the points. Yes, my friends. Next example is right. Next example is friends, if factor AB equal to, next example, if factor AB equal to 2i plus j minus 3k, and A is the point A with coordinates 1 comma 2 comma minus 1 is a point, then find the coordinates of other point B. Other point B. Yes, my friends. AB is given, OA is given, you have to find OB. In this case, my friends, you have to make use this result. Factor AB is given, factor OA is given. To find OB, AB plus OA is OB. By this, my friends, let O be the origin of reference. Then given factor OA is I 1 into I plus 2 into j minus 1 into k, and given AB, factor AB is given, which is 2i plus j minus 3k. Then we know that factor AB equal to OB minus OA. Therefore, OB equal to, from this, OB equal to, factor OB equal to factor AB plus factor OA. Yes, tell friend, what is AB? 2i plus j minus 3k plus OA. What is OA? It is I plus 2j. I plus 2j minus k. 2i plus I is 3i plus j plus 2j is plus 3j minus 3k minus k is minus 4k. What is this, my friend? Factor OB. From this we can write B. Therefore, factor OB is 3i plus 3j minus 4k. From this, my friends, coordinates of B, scalar components you have to write. They are the scalar components, coefficients of I, j, k. Coefficients of I, j, k. You have to convert from the factor to the point C. If R equal to or OP equal to xi plus yj plus zk, then what is the point P? They are the scalar components of the vector OP, which are x, y, z. What they are here? Coefficients of I, j, k, 3, 3, minus 4. They are the coordinates of it. Is another good example under 2 marks, my friends. It's a good example. 2 mark. I think it is appeared in the question, board exam question. 2 mark question. Yes, friends. The next question is, let's copy it. Yes. So that the points, next question is, so that the points A, its position vector is 2i minus j plus k. This is the position vector of the point A. You mean if O is the origin of reference, then vector OA is this. And B, another point, this is I minus 3j minus 5k. And C, another point. C, its position vector is 3i minus 4j minus 4k are the vertices of a right angled triangle. Yes, my friend. Position vectors of the points ABC are this. If O is the origin of reference, O is the origin of reference, then given vector OA is this 2i minus j plus k. OB is I minus 3z minus 5k. And OC, this position vector of the point C is this. OC is 3i minus 4j minus 4k minus 3i minus 4j minus 4k. Within this must find the sides now. AB. Side AB vector AB is what? By the result, position vector of the second point minus position vector of the first point. This is OB minus OA. I minus 2i minus 3j plus j minus 5k minus k. Yes, my friend. Then you wanted magnitude of AB. What is magnitude of AB? Is side AB. What is it? It is square root of I means minus 1 the whole square. This is plus 4 plus 36, which is root 31. Side AB is root 31. Next, second factor BC. It is OC minus OB. OC minus OB, 3i minus I. Minus 4j plus 3j. Minus 4k plus 5k. Yes, magnitude of BC, which is side BC. That is square root of 2 square minus 1 whole square plus 1 whole square. It is root 6. Next is CA. Vector CA. OA minus OC. OA minus OC. 2i minus 3i. Minus j plus 4j plus k minus of minus is plus 4k, which is 5k. So magnitude of CA is side CA equal to, which is square root minus 1 whole square plus 9 plus 25, which is 35. Root 35. Yes, my friends, we have done a mistake here. 36 plus 4 is 40, 41, not 31. It is 41. First, we have to show that the factors sum is 0. Factor AB plus factor BC plus factor CA equal to AB minus I minus 2Z minus 6K plus 2I minus J plus K plus this is CA. Factor CA is minus I plus 3J plus 5K minus J plus 3K plus 5K. Yes, my friend. Minus I minus I. I will have a mistake here. Minus I plus 3Z plus 5K. Minus I minus 2I plus 2I. 0 into I. Minus 2Z plus 3Z, otherwise minus 2Z minus J minus 3Z plus 3Z. This is 0 into K. Minus plus K plus 5K, 6 minus 6, 0. My friends, it is a 0 vector, not 0. Therefore, this is AB, factor AB plus BC plus CA is 0 vector. This shows vectors AB, BC, CA are the sides of the triangle. Sides of the triangle ABC. Then it remains to show that it represents a right angle. Represents a right angle. See, my friend, AB, side AB is root 41. Now side AB is root 41. Side BC is root 6. And the side CA is root 35. What is your verification? Therefore, my friend, BC square plus CA square. It is 6 plus 35 is 41. 41 is AB or AB square, my friend. 41 is AB square. Therefore, BC square plus CA square equal to AB square shows, therefore, AB square equal to BC square plus CA square proves that ABC is a right angled triangle. And where it is right angled? Right angled triangle with, my friend, angle C is 90 degrees. I tell AB square. See, if you wanted a figure, AB square. This is AB. AB square equal to AC square plus BC square. It is right angled at C, which is 90 degrees, my friends. 90 degrees. It is a good question under 3 mark. A good question under 3 mark. Yes, my friends. Yes. Next definition or result is. Next definition or result. Yes, my friends. Yes, copy it. Yes, it is easy, huh? OA, OB, OC written. With the help of this, you have to find the sides. First factors. Factor AB, OB minus OA, I minus 2I. You know the calculation, do it. Magnitude of AB is side AB, which is root x square plus y square plus z square. Minus 1 whole square, minus 2 whole square, minus 6 whole square. 40 plus 1. BC, OC minus OB, this. Magnitude of BC, side BC, root 6. Similarly, factor CA, side CA, root 35. First, you have to show that sum of the factors is 0. If the sum of the factors is a 0 factor, then these 3 factors represents sides of a triangle. So now, AB, BC, CA represents the sides of the triangle ABC. Then you have to show that it is a right angle. For that, Pythagoras theorem. AB, BC, CA. AB square plus BC here. It is BC square plus CA square. 6 plus 35, 41. 41 is AB square. So this shows what? By Pythagoras theorem, it is a right angled triangle with angle C equal to 90 degrees. 90 degrees. Yes. Next, my friend, one small result is there or definition is there. Then 2 examples for the verification, simple examples. Just 2 mark questions. 2 mark questions. Yes. You can say it is a result or definition, anything. You can say it is a result or definition, anything. Yes, my friend. 2 factors A and B are said to be A and B are said to be collinear. If factor A equal to plus or minus lambda B, or factor A plus lambda into factor B is 0 factor, anything, both are same. Even here plus minus also is a 0 factor. This is the definition of what? 2 factors are collinear. 2 factors are said to be collinear, which are A and B. Either you can express one factor equal to lambda times B, or their sum or difference is 0 factor. What about lambda? Lambda is a constant. Yes, my friend. One example based on this. Show that the factors A equal to 2I minus 3J plus 4K, and factor B equal to minus 4I plus 6J minus 8K are collinear. Yes, my friend. This is factor B. Minus 4i plus 6j minus 8k. What is common? Minus 2 is common. 2i plus 3 no. Minus 3j plus 4k. This minus 2 is taken outside from this, my friend. But what is this? This is nothing but factor A. So it is minus 2 times factor A. This gives, my friend, it is 2 times A plus factor B is a 0 factor. By this result, what you say? Implies A and B are collinear factor. Collinear. Yes, friends. One more. Yes, friend. If this is example 2, if I plus j plus k 2i plus 5j third 3i plus 2j minus 3k and I minus 6j minus k are the position vectors of the points A, B, C, D. Then show that factors AB and CD are collinear. Yes, my friends. In this case, directly the factors A and B are given. With the help of values of A and B, this is the relation. Vector B equal to minus 2 times the vector A or 2 times the vector A plus B. 0 vector means by this definition, A and B are collinear. In this case, first we have to write OA, OB, OC, OD. Yes. Let O be the origin of reference. O be the origin of reference. Then factor OA, first factor, it is I plus J plus K. Factor OB, it is 2I plus 5J. And there is no K term. When there is no K term means you can take it as what, my friend? 0 into K. OC is third vector, Pi plus 2J minus 3K. Then OD is I minus 6J minus K. Yes, my friends, making use of this, you have to find You have to find AB and CD, factor AB. It is OB minus OA, factor OA, which is, this is OB minus OA, 2I minus I. This is plus 5J minus J, 4J. This is what? 0 minus 1 minus K. This is AB, factor AB. Next we wanted factor CD. It is OD minus OC. OD minus OC. I minus 3I. Minus 6 minus 2. Minus K plus 3K is plus 2K. Yes, here itself we can know the relation. So, this CD equal to, this can be written as, you can take minus 2 common, I plus 4J minus K. After taking minus 2 outside, it is minus 2 into, what is this, my friend? I plus 4J minus K. I plus 4J minus K is factor AB. Therefore, factor CD equal to minus 2 times factor AB. Or you can say that 2 times factor AB plus factor CD is 0 factor. This itself shows what? The points lie on the same line, then factors are collinear. Implies factors AB and CD are collinear. Yes, my friends. Then you go with what? One example, DIY. DIY. Show that the points A minus 2I plus 3Z plus 5K B I plus 2Z plus 3K and C 7I minus K are collinear. So that they are collinear, points are collinear, my friends. Same thing you have to write. OA, OB, OC, write AB, BC. You find the relation. Yeah, AB, BC, CA, you find the relation. Yes, my friends, on this you do at home. Here, my friends, in this case, you get what? BC minus 2AB is 0. In this case, you get BC equal to, factor BC equal to 2 times factor AB. Then the points ABC are collinear. Points ABC are collinear. Yes, my friends, when the vectors are collinear, it implies what? Points A, B, C, D are collinear. Lies on the same line. Lies on the same line, collinear. Yes, my friends. These are 2 or 3 examples based on collinear properties. Collinear properties. My friends, in this case, the friend is given all 4 position vectors of the 4 points A, B, C, D. Then you have to go for what? OA, OB, OC, OD. I have written all the 4. Then you have to find AB, BC, I wanted to clearly mention AB and CD. AB, OB minus OA, CD, OD minus OC. Then here, CD is minus 2i minus 8j plus 2k. Minus 2 is common, you get what? I plus 4j minus k, if you take minus 2 common. This factor is nothing but factor AB. So it is minus 2 times the vector AB. Taking this side is this relation. 0 vectors means AB and CD are collinear vectors, hence the points are collinear, my friends. This is you have to do at home. You have to do at home. That result is BC equal to 2AB. You write the vector BC, you write the vector AB. So this is OA, OB, OC. What is AB? AB is OB minus OA. What is BC? BC is OC minus OB. You get the relation, this relation. That itself proves, my friends. Proves, my friends. Just you do it. You do it. Otherwise, if you wanted, write first the position vectors. Yes. The solution for this is the solution for this. This is OA. Minus 2i plus 3j plus 5k. This OB I plus 2j plus 3k. Yes, this is OC. OC, it is 7i plus 0 into j minus k. Find AB and BC. Factor AB, OB minus OA, I minus of minus, 2j minus 3j, 3 minus 5. Then BC. BC is OC minus OD. OC minus OD. 7 minus 1. 0 minus 2. Minus K minus 3K. Minus 4. Yes. You have to take 2 common. It is 3i minus j minus 2k. So it is 2 times. Tell what is this, my friend? Factor AB. 3i minus j minus 2k is factor AB. Yes. Therefore, BC equal to vector BC equal to 2 times factor AB implies factor BC and AB or AB and BC. AB and BC are collinear vectors. Then directed line segments are vectors means line segments are collinear means they have the same line, implies points ABC. Which these position vectors are collinear. Like this, even my friends, we can find AC. What is AC? AC is OC minus OA. You can get another relation. OC, I have to find AC, my friend. If you find AC, what is it? OC minus OA. You get another relation. You can compare with AB and BC, you get another relation. Like that, my friends. So, these are examples of collinear properties. Yes, my friends. This finishes collinear. Even we have done what, my friends? Direction cosine, some examples I've done. Direction ratios, some examples I've done. All these are very, very good examples. Even I have done an example showing it is a right angled triangle. Vectors represents right angled triangle. Yes, my friends, whatever I have done, all these are good examples under 2 or 3 mark questions, my friends. Okay, I hope enjoy with this. Then saying next it comes with addition and subtraction and scalar multiplication we have done. It is left with product of 2 vectors. That product of 2 vectors I do it in the next class, next video. Till then, my friends, bye, goodbye, namaste, namaskara, namaste, namaste. Yes, my friends.